maybe a little narrower. I don't know.
And how does that y equals x to 100 look like? That's the question. That's what I'm trying to get at. The question is, well, can you sketch that? Well, y equals x to 100. How about this? How about if you sketch this first? We know that when x equals 1, 1 to the 400 is 1. So we know that it's going to pass through this one, right, don't we? And then if you plug x equals -1, then we know that it's going to pass backwards. -1 to the 400 is still 1. And then when you plug in 0, we will get a 0 over here. So note that y equals x to 400 will pass through these 3 points. But then it will be multiplied on this and near the origin. Deeper as we go to the edges. No, let me not pick this. This is how the graph looks like. And by the way, this is what I want you to do. When you get into graphing, why don't you try to sketch the graph before you actually graph it? And when you graph it, this is what you get. That's that. Look at that. Look at that red. It's almost like a cow. What is that? Is there a calculation mistake here? It looks like that maybe the calculation made a mistake, right? But that's not a calculation mistake. So what I'm going to do is this. I'm going to erase this. Let me erase this. What is this here? Annotate. Let me erase this. Clear all this. And now what I'm going to do is I'm going to magnify this. Let's see what happens here. So this is how the graph looks like. Is it really a 90 degrees at the corner here at 1, 0? How does the graph actually look like? So this right here, let's look at this point 1, 0. We'll look at this here. When you look at this point right here, near the point 1, 0, it actually looks like this. There's a curve here. But it starts going up after about 0.99899 until x equals 0.98. It's almost 0. Now 0.99, it's about still less than a very small number. And then now as it gets closer and closer to 1, it blows up. That's how it looks like. So when you look at it from far away, it kind of looks like a cup. That's how it looks like. So these are the kind of things which you have to observe. So on the test, do you think I will ever give you something about these graphs? Yes, I could. I could. In fact, this is what I could do. What I could do is I could say this, and then this right here, and then I can actually give you the red curve. Let's see, I can do this, and then I can give you a curve like this. Then I ask you, what is the equation of this guy right here? So do you think I can give you that question on the test? Sure, I can do that. And I don't think you'll be able to use a calculator, right? If I give you, what is the graph of this guy look like? And then, of course, or I might give you a magnified version of this graph like this, and then you can guess it, okay? But anyway, always now when it comes to graphing, because I cannot give you the graphing problem, because everybody can graph it. I'm not going to give you that. I might give you the reverse problem. Reverse graphing problem. What that is I will give you the equation, and then I'll ask you to what? I will ask you to what? Get the equation like x minus 6. Let's look at this graph right here. You see, this is how the graph looks like. This is the graph of, you know what? It goes so steep here. So maybe to make it less steep, maybe I'll give you maybe this. How about 1 over 10? 1 over, okay, let's make it about 1 over 5. And there you go, that's a nice graph. If I give you a graph like this, you can get the equation here? Yeah, this one right here. So look, when you see a graph like this, what is that? Well, that kind of looks like a cubic, up, down, up. So that cubic, that's a pattern of a third degree. So if this is a polynomial function, if this is a graph of a polynomial function, again, not all graphs have polynomials, so don't get me wrong. There's so many other functions out there. Rational functions, radical functions, exponential, law, trigonometric, all kinds of functions out there. So if this is a polynomial, then this could be degree 3 or higher odd degree. But must be at least degree 3. This is not a quadratic. This is certainly not linear. Cannot be a quartic, or cannot be degree 4. It must be either degree 3 or 5 or 7 or something. That we don't know. But what is a possible graph? Well, there's a 0, 0 here, and then there's a 0 at 6, 0. So we have this, x squared and the x minus 6. And note that at 0, this is a pattern for a double root. So we have x squared. how would the graph look like if we have, let's say, like this? Let's say this one here. I'm going to copy it here. Oh. Okay, this. How the graph of, let's see, this one, let me change this. Instead of x squared, I'm going to have y equals x minus 6 squared over here. So how will the graph of this guy, how will this graph of number 9 look like? Now, number 9, what's the difference between number 8 and number 9? Number 9 has the x equals 6 is a double root, and x equals 0 is actually a single root. So how will that look like? Well, graph will look like this. What is it? Subscripts? I need to take out the subscripts, the superscripts. Okay, there we go. Now, let me click number 9. Now, can you guess how the graph of this number 9 is going to look like? Can you guess? Before graphing any equation, I recommend you to guess. Okay, don't just use a graphing calculator just to graph it. I want you to guess. Ultimately, you should be able to manually graph this. So, what happens if I give you a graph like this and ask you to get the equation? So now I give you this equation and ask you to get the equation here. And let me see. How about now? This is this here and this. Okay, now number 9. How does the graph look like? This is also a cubic, right? So graph is going to look like this. Oh, that's how it's going to look like. So that's what it is right here. Oh, that's how it's going to look like. So I can give you a graph like this and ask you to get the equation, which cannot be done by a calculator, which cannot be done by graphing calculator unless your calculator is a special AI calculator. Okay, there may be, but most graphing calculators they cannot handle this kind of problem. Okay, so all right, any questions here? Anyway, I'm not going to get into too much, and I do know that many of you already know this, so I'm not going to bore you. Okay, I'm not going to make it too boring. Okay, so that's that. And now what I'm going to do is now, let's see this here, and so that's that. And then, yes, of course, I have not done the rational exponents here. How about if I now do this? So, let me erase that, and then how about if I do this right here? And then we have, how about negative 1 over 2? Oh, there's a parenthesis here. What is that? This. Oh, that's how the graph looks like. Then I can go to a half here as well. Half part is the same thing as square root. It's the same thing as y equals square. Number 9 is y equals square of x, and you know how the graph of this guy looks like. Again, I'm not going to spend too much time, but why don't you play with the graphing calculator and make sure that you kind of know this. And by this, there's a difference. So by the way, you know what? Let's look at y equals x squared. This is y equals x to half power. And now what is y equals x to 1/3 power? 1/3 power is like this. So here, again, this red is y equals x to half power. So is there a difference between y equals x to half power and y equals x to 1/3? Yeah, there is. So see, the amount of bending is really different here. And then this, and then we have 2/3. Y equals x is 2/3. Where's the graph of this one? Not 2. It's 2/3 power. 2/3 is here. And how about this? Let me write y equals x. And this one is y equals x squared. How about y equals x? So y is equal to x to the 1.2. 1.2, 1.2. So let's do 1.2. Look at this. Y is equal to what? Now first, why don't we focus on the graph 0 to 1 by 0 to 1 by. How about if we focus on this graph? The 0 to 1 by 0 to 1. Look at this. What is the graph? The graph is y equals x squared. What's the one next to the graph? Is y equals what? Y equals the x to 1.3. Because 1.3 is slightly less than 2. And then the next one, the purple is the middle. That's y equals x. And then now what's the green? Well, green is y plus x to 2/3 power. The 2/3 is about 0.666. 0.66. And then comes the other red, which is about which is half. That's graph number 8. See this graph number 8 is this guy. And then the blue on the far right, on the top is y plus 1/3 power. So as you can see, as the exponent gets smaller, the graph gets pushed backwards, pushes that way. How about what do you think the graph will be if we have, let's say, y is equal to, let's say, how about x to the power? X to the power. X to the, let's say, how about 0.0001. How do you think the graph will look like? This guy is going to look like this. Look at that. You know what? Maybe that's too far. Oh yeah, like that. See, this one is number 14. This is how the graph looks like. Y equals 0 to x to the 0.01. This is actually the 100th root of x. And that's how the graph looks like. And the other end is, of course, y to the x to the 100th power. That's what you see right here. That's green over here. So what happens if I change that to 50? 55 or 55 like this? Okay, 55 still almost like a cup. If I change that to what? Maybe 20, 23, like still like that. Hey, you can play around with this. So I kind of want you to, how about this? How about if I call this guy A? A is, I'm using A right here. You know what, I can change this A, and as you can see, as A changes, this is what happens. You know what, when A becomes negative, the qualitative the graph actually changes. But A is changing, and the graph we have is y with A step. You see? That? You like my video? Do you like my graphing video class?
Yes.
Anyway, play around with all of these. Okay? There's a pattern. This is like a continuum. There's a spectrum. I want you to learn, these kind of things and get used to it. Okay? So you have to get used to it. Am I ever going to ask you to sketch? Am I ever going to give you a prompt like this? So let me stop there now. And now, and with this here, do you think I would ever give you a prompt like this? Like this here, and then like this, like a blue curve like this? Okay, I give you a graph like this guy right here, and how about, maybe that's a little bit too much. Maybe I'll give you maybe 0.1. And then I ask you, now maybe can make it 0.1 like this. And then I ask you, what is the possible graph of this guy? Well, you will be able to come up with an equation. Well, if you give me like y plus x equals a tiniest possible number, then you get this. Now, if this is negative, then of course it changes qualitatively. It becomes a different size. But anyway, again, I know that all of this is pre-calculus. I spend a lot of time on pre-calculus on these my pre-calculus side over all of these guys here. But again, here, okay, I think I need to save some time. Again, I don't want to bore you. I don't want to make it too boring. Okay, so anyway, I think that's good on that. I think I've spent enough time here. All right. So time to say bye-bye to these graphs here, and so now let's go back to our file. Okay, so this is 7.1.2. Our math class 0712. So when it says the file number is 0712, it means math 7, which is a calculus 1 class. And this is chapter 1, section 2, and then this is the first file. And so that's what it is. Okay, so anyway, these guys on example 5, you can look at it and see if you can guess these kind of graphs. And these guys are, in order for you to graph for example 5, you must know example 4. You have to master this one. This example 4 is not just a 3x3. This is not just random 9 problems. This number 4 is actually the set. So let me just write this here. Example 9, the 9 graphs right here, which I mentioned right here. This is the set of what? This is the what? This covers 9 types. 9 classes of graphs, y class of graphs covers y is equal to x to the rational. X to the what power? Rational function. Okay? X to the rational. M over, let me write this. Let me make it thinner. M over n power. What is it? M over n power. Okay? Yeah, the m kind of looks weird. You know what? Let me do it. I want to write this in. So this is what? This is m over n. M over n. So this covers all power functions with rational function, non-rational. Again, if you make an operation, there's a common thing for the first. There's a reason why I wrote down 3 by 3 table in a table form, 3 by 3 parts, and you have a 9 list of 9 functions. But every column and every row has something in common. That's why I put it this way. Okay, so this one here is what for I is on the m over n. This is y is equal to. This is y is equal to. This is y is equal to. That's the power. Let me write this. This right here. Look at the second row. Exponents are 3 over 2, 5 over 5 thirds, and 4 thirds. Yeah, in this case, the exponent m over n is actually bigger than 1. If you look at number the bottom, yeah, here you have m over n is actually negative. M and n are integers, by the way. And m and n are integers. Here, let me write where m and n are integers. It could be negative too. Of course, n is not 0. N not 0. Okay? N is not 0. N is not 0. Okay. And then what is the common thing for the first column? You see, half and negative 3 halves. Half and 3 halves and negative 3 halves, so negative 1 half. Oh, in this case, what is this? This is m over n. What is that? This is auto reason power. Auto reason. And if you look at the second column, I'm not going to write again. I'm not going to write anymore. It's auto rod power. And then if you look at the third column, it's even of rod power. So there's a common thing for every column and every row. And because of those algebraic similarities, there's also a graphical similarity. There's something common graphically for each column and each row. Okay, anyway, and then you have to master this if you really want to get to example 5. Example 5 is a little bit difficult because we now get into rational exponents. We can play around with it, but they are related. Example 4, all the graphs in example 4 are building blocks. When you have a half power, so again, when you have half power, okay, let's see, when you have this half, so let me show you this half power right here. So half power is this. When you look at example 1, this is half power. So this half power is kind of like this. And then this 2/3 graph is actually going to look like this. And then if it's negative half power, the graph is actually going to look like this. Okay, again, I'm not going to spend too much time explaining this. And now, if you look at example 5, and then let's say you have, let's say, how about, where is it? Oh, you have this 1/3 power kind of looks like, let's see, like this. 1/3 power, I graph this, and they kind of look like this. It comes vertical here and goes like that. Now, Does this graph of y equals x and 1/3 have anything to do with this guy right here? Example 5, part A, this guy right here. You see the bottom. This guy. This is y equals x and 1/3 power times x minus 4. So do you think this graph will have something to do with this y equals x to 1/3? And the answer is yes. This guy here, yeah, we can graph it. This square is 4/3 power is going to look like this. Yeah, so this one, the graph is going to actually look like this. And then we have this, and then we have 4 here. You know what, let me just do a fast graph. Yeah, this is single here. A single is a cut. And this one is 1/3 power. The graph is actually going to look like this. And then it's going to become vertical here. And then push down this way. And then that. Oh, that's how it's going to look like. You know what, this graph, you know what, I'll just go to the decimals, and then how about if I just show you how this graph works, okay? So let me just graph this here. So I'm going to do a save and then clear all this. What I'll do is I'm going to, let's go to the graph. And the graph is right here. Am I sharing this page? Yes. So let's look at that. Let's graph it. So what's the equation? Oh yeah, the equation is on. Oh, the equation is this. X what? X minus 4. The graph of y equals x to the 1/3 power times x minus 4, the graph looks like this. Oh, you know what? Near the origin, this is how it looks like. If you look at the big picture, oh, the graph looks like this. Oh, what is this? Class, do you like these graphs? Class, do you like these graphs? What's that? That's how the graph looks like.
I'm not sure I really like this graph.
You don't like
it
it?
scares me. It scares me.
You better like it. You better like it, okay? But again, you know what? Try to learn as much as you can. But anyway, unfortunately, cannot spend too much time on this. But this part right here, this, you know what? Basically, what we have is this part right here. This part right here. This is the pattern of a single. This is 4 here. This is the pattern of a single. This is what I call a cut. So this pattern is a cut at 4,0. That's a 1. But this pattern right here, this is a 1/3 pattern, 1/3 root pattern. This is at 4, it's multiplicity 1. At 0, at the origin, it's multiplicity 1/3 pattern. That's why you have this 1/3 pattern. So if I, let's say number 13. Number 13 is this guy. Number 13 is 1/3 power. Is this. Number 13, the graph is going to be this, red. Now, it's different, right? Well, how about if I now went near 0, this is like -4. Now, when you look at the blue and the red, it looks very different, right? However, if I put a, how about if I put a -4 here? It looks like this. -4. You know what? This blue graph and the red graph, near the origin, they look very similar. So if I magnify this, look at this. You see a similarity between the blue and the red. Because blue and the blue and the red, both graphs near the origin, the multiplicity is 1/3. So both x to 1/3 power. And because they both have x to 1/3, they look alike near the origin. But if you look at the whole graph, it's shows they're different. How about number 15? How about near x plus 4? Near x plus 4, x minus 4. How does this graph look like? Now, do you all know how the graph of y plus x minus 4 looks like? It looks like this. The blue graph kind of looks like a green graph, right? But in this case, if I now put in, let's say 4 to the 1/3 power, 4 raised to 1/3 power.
These guys worked out this morning. Are you serious?
Like this.
Tomorrow we're getting
Do you know what you see now? This number 5 graph is a line, but the green line and the them, when you look at the intersection at 4, 0, that is at the point 4, 0, they kind of look alike. See? The blue and the green, they kind of look alike. So number 14 and 15, their behavior in F204 is the same. And anyway, you know what? There are all kinds of things I can do here, but anyway, I think this is good enough for now. So I will now, I think it's time for us to say bye-bye to these problems. And, okay, I want to play around with these graphs here, so that's what I want you to do. Okay, so that made me annotate. Let me clear all this. Now time to go back to the file. What I like to do is go back to the file. Okay, section, we are back to section 1.2. Yeah. So again, I just don't know what to say one more time, but all the equations you see on example 4, this is not just a random 9 problem, but this represents the class. This is a 9 example. Again, represent this from represent 9 classes of our functions with rational exponents. Rational meaning fractional exponents, like 1/3 power, 2/3 power, 4/3 power, -1/3 power, -1 power, -3 power. And you know what? If you master this, then you basically master the entire group of power functions with rational exponents. You actually master it. Okay? So anyway, that's that. Okay, but anyway, again, I think this is fun, but I think we have to say bye-bye to this. Bye-bye to this. It's fun, but again, cannot have too much fun. And then comes the example 6 here. Now, example 6, these are monsters. They not only have fractional exponents, positive, but we also have negative exponents as well. Now we have things in the denominator. So now it becomes more interesting. Okay, but anyway, you can try to graph them and see, how they're similar. But again, I'll make more. You know what I'll do is throughout this course, you are going to see these kind of functions, and I will make comments as they show up. Okay, so I'm not going to put too much burden on you, but the more you know, the better you will be. And these are very important examples. You have to study them. For example, if you look at example 4, class I, then we have this x to -2 power. So what is the graph of y equals 1/x squared? How does the graph of this guy look like? Oh, this is what I call a volcano. You like the volcano? What is this? What is y equals 1/x? Y equals 1/x is a volcano. So let me say, let me just clear this. What is the graph of volcano? Let me go back here. So what I'm going to do is I'm going to do this, and then how about this, unflip it. And let me erase all of these guys here. And what I'll do is this here, 1/x. Oops, that's squared. How does graph of y equals x squared look like? This. Graph number 1. This is the graph. This graph is the graph of y equals x squared. It's like a volcano. You have this graph? Now, if you look at the graph of y equals 1/x, which are very familiar, of course, this one everybody knows. This one looks like this. Purple. Yeah, we know that. Then how about this one? This one here, number 13, y is equal to 1/, and x cubed. This is going to follow the pattern of y equals x. Very similar. Is this. The number 14, let me just do this, okay? I guess I cannot control myself here. I'm doing a little bit more than what I should, but 4th power here, 4th power. Yeah, this one. Okay. These are the graphs here. Look at that. Isn't that similar? Yeah, they're similar. Kind of similar here. But if you look at number 1 and 3, they both happen to be purple. Anyway, I can change the color, but you know what? Can I change the color? Okay, let's change the color. Oops. Can I change the color? Change the color. Green. number 11 is 1 over x, and the purple is 1 over x cubed. If you look at the big picture, they kind of look similar, but the amount of bending is different. How about if it's y plus 1 over x squared? Now, 2 is an even number, so now it's going to be different. Now, if you look at this y plus 1 over x squared, on the positive side, when x is positive, it is right in the middle. The black curve is right between the purple and the green. You see? Because 2 is between 1 and 3. But on the left-hand side is different, because 2 is even and 1 and 3 are odd. So there are all these properties here. But what I like to say is, when the equations are similar, then the graph looks similar. So that's when the graphs are similar, the equations are similar. There's a similarity between the relation between the equations and the graphs. So this is actually what I'm trying to get at. Again, when the equations are similar, then the graphs are similar. Okay? So I can have a whole lesson on this, but I think it's only 9:50. Oops. And when am I going to start section 1.2? Okay, so anyway, that's that. Okay, so what I'm going to do is let's now go back to the files here. Okay, so we have this. I just want to make a comment here. And then that's 1.2a. And the 1.2b is this guy, rational functions. Now, if you look at section 1.b in example 1, these are power functions translated. So power functions translated with negative exponents. All of these questions are basically this right here. They are y is equal to what? Y equals to x minus 3 to the negative exponent. In this case, all the exponents are actually negative integer. So I can say they are negative integer exponents. What is this? Negative integer. Negative integer. Okay, so we can also write it that way, and then of course, graph this. These are all power functions as well, but this is what a function translated. So the entire graph shifted 3 to the right. Okay, so anyway, that's that. And then right underneath that, there are all these the rational functions. These are called rational functions. Rational functions. A variable must be in the denominator. A variable in the denominator. Okay, in the denominator. If there's a variable in the denominator, it's called a rational function. Okay, anyway, that's that. And then let me now scroll this over here. So this is here. Annotation, save this, clear this. Now there's some definition of asymptotes which we will study in this course, of course. And now this is calculus, so we will actually study these guys here. It will come up very soon. And then we have all these asymptotes of graphs of rational functions. I might have mentioned this already, but anyway, read these paragraphs. Okay, now, you know what I'm going to do now? I'm going to say bye to these guys, and now let's look up the other file, 1.3c. 1.3c, trig. All of you, do you love trig? Do you love trig?
No.
You don't love it?
I
When
do.
you get to chapter 3 in our course, you will get to trig, okay? So there's no way to avoid this. But the question is, should I give you a trig on midterm 1 and 2? The trig, I think, shows up on chapter, actually shows up on chapter 2, right? Does it show up on chapter 2 or 3? I think it shows up on chapter 2. So midterm 1, do you think I should give you a trig? No? Or should I wait until midterm 2? Anyway, all of these trig here, yeah, I understand. I think some of you completed through all the trig, right? So, I'm not going to, I won't give you a trig on midterm 1, okay? But anyway, I tried to review this section as well. You have to review the entire trig. We do need this and that, the few things of trig, because we will cover calculus of trig functions. I think it shows up in chapter 2. So anyway, I'm going to skip that for now. And now let's move on to section 1.3. So 1.3 is about transformation. Transformation is basically this right here.
Hey!
If you know, like graph, if you know the graph of y equals f of x, then how do you graph y equals f of x minus 1? X plus 2. Again, this one, I think some of you may know it, some of you may not, so I'm not going to cover this right now, but anyway, these graphs right here, and then we talked about translation, and then we talked about reflection, and we talked about what, the stretch and shrink, or compression and expansion. Sometimes we call this dilation. So some would call this dilation. I call it stretch and shrink. Sometimes it's called compression and expansion. So what that means is, you know what? Is it almost time to have a break? Yeah, it's time to have a break. But let me just finish this here. Let me go to the graphing calculator here one more time. I'm just back here again. So in this case, let's say, how about the y plus x minus? How about, let me just do, how about square root of x? Let me take y to square root of x. Where's square root? Yeah, square root right here. And x, there we go, that's the graph right there. So how about if I do, what did I do? Oh, there we go. So I thought, now if you know how to graph y equals x, y equals square, this is y equals square root of x, by the way. This is y equals square root of x. How do we graph y is equal to, how about this? Y equals x minus 2. Do you know how to graph this one? If you know the graph of y equals x, y equals square root of x, then do you know the graph of y equals square root of x minus 2? You know how to graph this one? What do you think? If you replace x by x minus 2, you know what happens to the graph? The graph gets shifted to the right. I don't know, have you seen this graph?
And that's because the root for that particular equation is 2, because that will give us 0.
It has a point 2, 0 exactly. Now, of course, these are equations which you know already, right? So if I ask you to graph number 12, y equals square root of x minus 2, then everybody will know how to graph it. Now, of course, what I can do on the test is I can give you these graph number 2, graph this, graph third, and then ask you to get an equation. Get a possible equation, okay? So, well, this is like y equals square root of x. And so we know that this guy kind of looks like y equals square root of x. Yeah, this one kind of looks like it is y equals square root of x. So what is the equation of this guy right here? So what is the equation? So I can give you this, right? So the question is, well, if you now compare the green and the black, what we do see is that this graph is translated 2 to the right. See this one right here? This guy is 2 moved 2 to the right. And then we have this one right here. This guy is moved 2 to the right. It's actually not 4, it's 2, because there's a half block here. So what you do to go from here to here, move 2 to the right, and this is the pattern. If you replace every x by x minus 2, if you replace x by x minus 2, what does the graph look like? The graph will get shifted 2 to the right. And this is therefore y is equal. The equation will be square root of x minus 2. Of course, I can use this one too. Anyway, you know what? And you can also go not only from green to black, we can also go from what? We can also, what is this here? Let's look here. What is my scale now? I must be now. Let me try to fit this here. Will it fit? Yeah. Oh, there you go. Kind of fits. Okay. So you can go from green to black. If you want to go from green to black, we have to replace every x by x plus 2. But we can also go from black to green. If you want to go from black to green, what happens is we have to move 2 to the left. If the graph is moving 2 to the left, what is the substitution? The substitution is replace x by x plus 2. So if this is the equation right here, if this equation, y is equal to x plus 2. If you have this equation right here, replace that x right there by x plus 2. So if you replace that x by x plus 2, then we actually get the green graph, which is y plus 4 of x. We can go back and forth, but anyway, you know what? Again, I'm going to ask you to study the topic of transformation, section 1.3, on your own as well. Okay? So anyway, as they show up in this course, I will go over, but the more you know, the better it will be. Okay? So it is covered on most, in practice, all pre-calculus textbooks. Again, they are covered in pre-calculus textbooks. Also, many intermediate level textbooks, they have that topic too. Okay, so it's not really a calculus topic, etc. So I will go over as they show up in this class. Okay, so let me now go back to files here, and that's what it is. So let me share. So that was section 1.3, and then learn as much as you can, reflection and all that. Okay, and as they show up, I will go over those topics as they show up, because I don't want to spend too much time here. Now, after this, we now get to section 1.4, and this is actually the topic which I want to talk about. It's 10 o'clock. We have only 15 minutes. Let's still have a 10-minute break, because I would like to start a new topic here, okay? So let's do it. So how about if we take a break right now? I know it's a little bit too late. 10-minute break. Let's continue at 10:10. 10:10 a.m. Okay. Now, I think I need to have a break too. So if you have any questions, you can ask me after the break. Let's meet at 10:10. 10-minute break, everybody.